Okay, we're going to take the techniques that we learned in our previous chi-square now, testing whether the proportions are the same, and we're going to use them to check whether a model fits. Okay, case study. Vinny the Weasel has been involved in an illicit game of craps and believes his opponents has been using a modified dice. In order to test whether his intuition is accurate, he obtains his opponent's dice, and while his opponent is regaining consciousness, throws the dice 1,000 times, obtaining the following results. Okay, so we get a sum of dots here, right? Because this is what we're interested in, and we get this frequency for them. Okay, so he had 3 turn up 104 times, for example. Now, when you're playing dice, there is a simple probability model for them. You get 2, 1 in 36 times. You get 3, 2 in 36, and you keep going up the number of times over 36 until you get up to the 7 dots, which there are 6 chances out of 36 of getting. And then it goes down again until we get to 12 dots. Okay, and with these, we'll calculate them as probabilities like so. And so we prepare a table. The first column is the number of dots. The second column is the number of times Vinny observed getting each of the times of dots. So the first 2 columns represents a frequency table. The third column, this is what the standard probability model for dice predicts would happen for fair dice. And so we take like 0.028 times the 1,000 times he threw the dice, and that gives us a 28, for example. Now here on number 6, okay, the standard model gives us 0.138. We multiply that times 1,000, and that gives us 138. And again, do this for each of the different probabilities. Then we check how far each of these is out of line. For example, in the 4 column, we observed 70, we expected 83, so we take 70 minus 83, square that, and divide that by 83. This gives us 2.036, and we do this at each column, and then we add it all up, and the total amount this is out of line is 156, which looks awfully big, but to know for sure we have to look up the chi-square chi-square critical number at the correct number of degrees of freedom. So here we have 11 different categories. We take 11 minus 1, that gives us 10 degrees of freedom. Our critical number for a 0.05 significance level is 18.307, and 150 is bigger than 18. So Vinny's intuition was correct in this particular instance. Okay, I'm going to do another example here, and this is kind of a cautionary tale because the test isn't perfect. Okay, so what I did, I took my Excel spreadsheet and I did a little work with it. I conducted an experiment, a binomial experiment with 10 trials and a probability of 3 success, and I repeated this 100 times. Okay, and so I obtained this data here, and again, the probability of success P was 0.3. Okay. I then took this and I fiddled with it. I looked at the probability model here for 0.5. Okay, so this is the probability model, not for 0.3 like I tested, but for 0.5. Okay, and I put this in. So I take this is the probability for 0.5, and I multiply that times each of the ones in my experiment, 100, and I get, these are my expectations of success right here. And I then, okay, match how far what I really got in my real experiment against what I expected. Yeah, I did the math on each of these, and this is what I got in each of the categories. I then added those up, and this is the amount that my 0.3 data was out of line with my 0.5 probability on the BNP, right? I did the table lookup and got a critical number of 18.307, but I can't reject because the amount is out of line is not greater than 18.307. So this is a situation in which the chi-square is not helping me to reject a phony probability model. There could be enough random variation in an experiment wherein a 0.3 could look like a 0.5 on the binomial. Okay, so this is sort of a cautionary tale that this isn't a magic bullet. Example 2. What I did here, I took data, okay, on a 0.4 and tested it against the model for the 0.5. Okay, so this is my data I conducted for a 0.4, and I tested it against the 0.5 probability. So this is the same stuff as before. I did it, and here I got the chi-square 24. The chi-square test statistic, having run through all of these calculations. And so here I do reject it. Okay, this is even though the 0.44 was closer to the 0.5 than the 0.3 was. Okay, so here it is able to distinguish it, and before it wasn't. Sometimes the random variation is just is just there. Okay.